Thank you for coming to our corrosion session. This is going to be a little different and a lot more informal than what you're used to at these events, mostly because this is going to be run like a relay. We have a lot of wonderful information to share and some great speakers and not much time at all. It's important to note that you have two forces represented here. We've got the Emerging Fuels Task Force and the UST Task Force, and we also have OUST. So I'm going to turn it over to Mahesh. Mahesh Albuquerque is the director of the Division of Oil and Public Safety in Colorado. He is also our task force chair, and he's going to lead us off.
Thanks, Tara. Tara is actually on our Emerging Fuels Task Force, and she's the vice chair. And as she said, we do have a lot of information to go through in this next session, and so I'm going to be quick. What I'm going to try to do is really give you all a high-level overview of the task force and some of the talk about some of the things that led to some of our work products, and actually have a lot of our members out here get into more detail on specifics out here. So kind of starting out with this task force, it was formed a little over 3 years ago, and it was really to provide states with resources to deal with emerging fuels. So the fuels we're talking about are the traditional ethanol blends and biodiesel blends, and now we started off as Alternative Fuels Task Force, and now we've changed our name to the Emerging Fuels Task Force, and so that's pulling in ultra-low sulfur diesel and some of those issues. But we have representation from, or we hope to have representation from all 10 regions here. And if you notice the slide, we have a vacancy there. So anyone from Region 5 that you know of that has interest in joining our task force, we'd welcome that person out here. I think everyone else on our task force is here except for Doug from Texas and Laura from Missouri. But Laura has Valerie sitting in the audience here, who's kind of sitting in for her at this meeting. So just a little history on some of the fuels that kind of caused us to start looking at compatibility and corrosion sort of issues and how they came to be in fuels. So way back in 79 is when the Clean Act Air Waiver allowed for 10% ethanol into gasoline, and it came in as gasohol, and now it's the E10. But then later, with the Energy Policy Act in 2005, and we focused more on the underground storage tank provisions. There were also the renewable fuel standards. That, along with the Energy Independence Act of 2007, caused an increase in the usage of renewable fuels and conventional gasoline. And then most recently, in 2011, now there's an allowance to use to go up to E15, 15% ethanol in these fuels. I kind of was on Google and went to this website. This is kind of a pro-ethanol website, and they talk about, there's some good information on ethanol usage in fuel, and some facts out there, and clearly this is true. There's ethanol in almost all of the US gasoline. And there's almost all gasoline in the U.S. contains 10% ethanol. So it's definitely out there, and they called it the ethanol effect. This is the ethanol effect we see, and I think a lot of you all have seen this for the last 10, 20 years since the tanks program came into existence, and ethanol was already in tanks. But we've seen severe corrosion in containment sumps, especially very obvious, the copper corroding, as well as just all the metal components. We've also seen, this is actually from a New EPIC document where they partnered with EPA and state of Tennessee. But I think you'll have seen these pictures at prior tanks conferences too, especially the ones on the bottom. If you notice, that was a sump installed in March of 2010, and 5 months later, it's already corroded. And there's a lot of work that's been done related to causation and all of that. But this is kind of what we've seen on ethanol sumps. The kind of take home is it was very obvious in containment sumps. So now switching to diesel, which will be a lot of the rest of our presentation too, is how did, what's with diesel and why are we concerned with it more recently? So in 2001, there was the highway diesel rule that required a significant reduction in sulfur in all of the fuel, diesel fuel in the US. So it was going from 500 parts per million sulfur down to 15 parts per million. And this kind of hit the retail outlets and the marketplace in 2006. So, and then there was a phase-in period between 2006 and 2011. And now everything in the US is ultra-low sulfur diesel. So diesel is ultra-low sulfur. You can't get any other sort of diesel. I know we did a survey through Oswamo recently, and a few states responded saying, oh, we don't have ultra-low sulfur diesel in our state. And that's absolutely not true. You can't get anything but ultra-low sulfur as a diesel fuel. So kind of with that 2006 date, we also started seeing issues arise. And I'm sure some of y'all are familiar with some of these things that we've noted out here. But inspectors started seeing fuel seeps in dispenser containment. There were owners that would talk about having to replace their filters a little more frequently, some erratic operation of tank gauging systems, the floats and stuff. And then as we started looking into tanks, we started noticing that there was actual corrosion on metal components in both fiberglass and steel tanks. And one of the significant differences with this, another take-home, is the corrosion was not evident on the surface. So if you looked at the diesel sump, it looked pretty good on the outside. You didn't see all the pitting and corrosion and all that we saw with ethanol sumps. So that's kind of one take-home. Here's just a picture of a leak from a dispenser gasket housing. And this is a picture that we had from one of our inspectors way back in 2006 or 7. Newly installed dispenser, and pretty soon after that switch gasket started leaking. But then this is more of what we actually, we've been looking at, the rusted submersible pump shafts and other metal in-tank components. So just some thoughts on what the reduction in sulfur may have done and why we are seeing some of this. So one of the obvious things is reducing that sulfur 97%, going from 500 to 15, almost takes away some of its kind of antibiotic or properties. Yeah, sulfur is used as an antibiotic in antiseptic creams and all that. So there's some of that that's could be related to loss of its antibiotic properties, but it also acts as a natural antioxidant. And when you diminish that, you allow oxidation to take place a little more rapidly. And oxidation on metal is rust. Yeah, and that's may explain some of what we've seen in tanks and what you'll hear about from some of our other speakers out here. I kind of threw this table together just to do a little quick compare and contrast on like the affinity for water on the ethanol blended alcohol fuels. It's extremely high on the biodiesels and the diesel ultra-low sulfur. It's less. The volatility again on the alcohol gasoline end is high, whereas lower on the diesel. Fuel susceptibility, microbial growth, and presence of water is high on all of them. And then the external and internal manifestation on the alcohol blends, it's been more external in sumps, whereas with the diesel, it's less volatile and not so evident on the outside. And then kind of the last point is one of the big take-home messages too. I think it's really critical to manage water. Biological activity can be enhanced in the presence of water. So if you want to try to minimize the microbial induced corrosion or those sorts of effects, one of the options is to kind of manage your water. The Steel Tank Institute had a great paper out way back in 2004, and they've updated it since on how water gets into tanks. And clearly it's from a lot of tank top fittings and all of that, but it also comes in through transports. And you'll hear later, it may be water, it may be cross-dropped fuel, which may have some ethanol and diesel also that could be contributing. Tanks at the refineries and terminals are agitated to keep the fuel composition consistent. But what that also does is it doesn't allow water to settle. It agitates that water, mixes it in. The sediment in those big tanks gets mixed in. You put it on a transport truck, and then it sits at a retail station. That's where it'll start separating out. And so that's kind of another form of entry into a storage tank system. Just some resources out here. The Clean Diesel Fuel Alliance, if you Google that, they have some great information on ultra-low sulfur and some guidance for retail operations and storage. And one of the things that they kind of point out, again, in this guidance that I've highlighted, is the importance of water management. They talk about a quarter-inch of water in a storage tank is enough to trigger microbial activity. And so I just pull this up there to highlight the importance of water management. And then I think many of you all have seen this document that was released by the Coordinating Research Council and working with some fuel companies as well as ASTM. And their guidance also, it's a kind of a two-pager, is no detectable water is desirable. If found, should be removed as soon as possible. Test for microbes. You hear Mike and John talk about how you can do that a little later in our presentation. So I wanted to highlight the importance of water management. This is really kind of what our task force has put out recently. It really isn't a new publication. It used to be, we released this, I think 2 or 3 years ago, called the Alternative Fuels Compatibility Document. We've changed it, updated it, and now it's been released earlier this year as the Compatibility Considerations for US Systems, really dealing with emerging fuels. And in it, it's really got a wealth of information. If you haven't seen it, it's on SWAMO's website. You can download it from there. But it's got compatibility evaluation checklists and templates that your state can use if you don't have anything in place. It's really got a cool compatibility evaluation toolkit that Ted's going to walk through. And then we did a survey of states for the last couple of years on compatibility types of issues with ethanol blended fuels and biodiesel. And Kris is going to talk about that survey and what we've done with that survey. And he's done some pretty fantastic stuff with how we present the results that he'll share with you. It's got a ton of links to helpful resources, everything from, obviously EPA's website, but other documents that have been out there, a lot of information from STI, PEI, and all of that. And something that we're looking at coming out with pretty soon is an online reporting toolkit that will actually allow everyone or anyone to submit information to our task group. One of the things that we've noticed is we get these, somebody will call us or one of our members and say, hey, here's what I'm seeing in my state. Leanne from Montana just reached out to us the last couple of weeks on an issue she was having, but we thought it'd be great if we could have a common repository for all this. And so that's what this online reporting portal is, we hope we'll be able to do, and we hope we'll be able to release that in early 2007. So that's kind of the quick overview of what you're going to hear more about. What I would just remind you again, we have 10 members, and these people are your regional representatives. So really make it a point to get to know them if you don't know them already, because they are the ones you need to reach out to if you have issues related to any concerns on compatibility or corrosion that you're seeing with emerging fuels. So kind of with that, I'm going to hand it over to Kris Grinnell from the state of Washington, and he's going to talk about our survey and how he's been able to kind of share the results of that with everyone. So, Kris?
Thanks, Mahesh. All right, so as he said, we sent a survey out to all the states and had them give responses. So what we ended up with was a really big and somewhat complicated spreadsheet. You know, more than 50 rows, more than 30 columns. A lot of them are free text. So, you know, how do we make this? How do we, you know, present this information in a way that is useful to you guys? So, I had just recently been in a couple of meetings where somebody was showing story maps, and during a conference call, I'm like, hey, we got a guy here that I think can do this, so let me ask him, and this is what we came up with. So it's going to be posted on the SWAMA website. It's supported by Esri. It's a free service that they do. So basically what this is there's a bunch of tabs along the top. And this, on the left, it just sort of describes what was in the survey and stuff. So I'll get right into it. So if you click on a tab, get the U.S. centered right there. The states that provide information show up in different colors depending on, so this first tab just describes the infrastructure that's out there. We thought that was sort of a baseline that we could start with. So, and then if you go to each individual state, you can click on the state, and it'll give you a little bit more detailed information on that state. So, so we had a pretty long discussion about what the tabs should be and stuff like that. So these are the tabs we came up with. As you can see, we didn't get input from all the states, but we're still accepting data if anybody wants to supply more data. So let me just click through some of these. The second one was whether or not states had defined biofuel in the statute. This one's pretty simple. It's yes or no. But then, you know, if you click on it, you can get sort of what their response was, similar to the other tabs. And then which states verify compatibility. That's pretty self-explanatory as well. I think the answers show up. And then this question, so the next one is ethanol corrosion, and the question is, you know, are you seeing compatibility issues, seeing corrosion? The way the question was posed in this one, it was kind of whether or not you'd seen leaks as a result of ethanol, and because the corrosion that Mahesh showed in his pictures doesn't necessarily mean that the tank's leaking. These, and you know, it may not be totally representative of what of the problem that really exists. Similar, how many states are, you know, aware of issues with compatibility? And this is with ultra low sulfur diesel. And then this last one was, you know, do you have the enforcement authority to have a tank removed if it proves to be incompatible, if it's holding a substance that's not compatible with what the state, with what the tank is. So yeah, I mean, this was just our way of trying to present the data in sort of a way that you can be interactive with the data and not, and instead of, now if you want to look at the whole spreadsheet, it's still available, but, and it will be attached to the report ultimately, but this is the data we chose to portray in this method, and I don't know, I think everybody, it seems to be well received so far, but that's really all I had. I think I put this back up here. I think I will turn it over. Oh, here. Thank you.
Thank you, Kris. I'm going to quickly go over the report that Mahesh mentioned and also show you the online compatibility tool, which I have to say I think is one of the slickest things I've seen in a long time. Mahesh already showed you the cover of the report, so you've seen that photo. The report is intended for multiple audiences: regulators, tank owners, operators, contractors, all that sort of stuff. So it is broad in scope. Obviously, the issue is compatibility of biofuels and emerging fuels, and by that, we're really referring to ultra-low sulfur diesel. It's not a biofuel, but because of its different formulation, it's posing some interesting issues. So we've got a summary of the compatibility challenges that these new fuels are causing, a list of references and links to additional resources. If you want more information, this is a great place to go, because the report contains a lot of information, but even more so, there's a long list of other references, so you don't have to spend half a day Googling things. This will already point you to a lot of good sources. Got some case studies of failures which we don't know for sure were caused by corrosion, but by incompatibility, but probably. The online compatibility tool. The report was originally issued about a year ago, and it was updated this past May. It also contains this form which basically helps you go through step by step addressing compatibility issues. The form can be customized. I mean, it's intended to serve as a template. It can be customized for whatever you want. One issue that we want to remember is that compatibility, there's a number of issues involved with this. And the most obvious one is whether or not a component is simply compatible with the type of fuel you're dealing with. And for the most part, that tends not to be a huge issue as long as you're using something that is compatible. There are some gaskets and pipe dopes and things like that that are not alcohol compatible, but those are fairly straightforward. The issue that we really need to think a lot about is that compatibility also, a lot of times if something is compatible with the material stored, that doesn't mean it's compatible with a decomposition product. So you might have something that's compatible with ethanol blends, but that doesn't mean it's compatible with the acetic acid that the ethanol can turn into. That's the point I'm trying to make. The online compatibility tool is, as I say, I think it's just really, really slick. It's not live yet. It will be on the ASWOMA website sometime after the new year, right, Charles? Okay, Charles says yes, so you can take that to the bank. And it's a great way just to get access to manufacturers' compatibility statements. And I'll just take you through an example. Let's say somebody has submitted a permit application. They want to install a new B99 tank, and they plan to use an overfill prevention device that's made by Vaporless Manufacturing. Now, I know that Vaporless only makes overfill prevention devices for ASTs. Just work with me. This is a completely fictitious example. So we go to the online compatibility tool, and we click, there's a drop-down menu there, so we click on do it by fuel type. You can also go by component thing, but by fuel type, next thing, we choose biodiesel blends greater than B20. Click continue. Next thing, that takes you to the biodiesel page, and I don't know how well you can read that, but I've clicked on spill and overfill prevention equipment. Click on continue. Then we get a list of manufacturers, and you'll notice that this list is not complete. There's plenty of other manufacturers of devices that aren't listed yet, and we'll get to how we're expanding that list. But in this case, we click on Vaporless Manufacturing, and it takes us straight to the manufacturer's statement on compatibility. Now, the reason I chose Vaporless is because when I read this paragraph, I was really taken aback. What it says, I think you can read that, but it says, if you're using our component with biodiesel blends greater than B5, then you need to replace all the copper and brass components with stainless steel. And conventional wisdom holds that if you're B20 or less, it's essentially identical, at least from the point of view of compatibility, it's essentially identical to regular old diesel. And so at least with this particular device, if you're using anything other than ultra-low sulfur, because remember, ultra-low sulfur can be up to B5, but if you're using any biodiesel blend greater than that, you need to replace the stainless steel parts, the brass parts with stainless steel. The lesson here is, even if you're not dealing with an exotic fuel, you really do need to pay attention to the manufacturer's compatibility statements. We as regulators need to do that. The industry needs to do that. Everybody needs to do that. If something is missing, and as you could see, there's a number of things that are missing, people can fill out this simple form and submit it to us. The task force will take a look at that. It's not like Wikipedia where anybody can upload whatever they want. Submit it to us, and then we'll decide if it goes on there. But that's how we can update and expand the listings. And I wanted to conclude by saying it's been my honor and privilege to present all this cool stuff. But the truth is, I joined this task force relatively recently, and all the grunt work and the heavy lifting for the report and all the work on designing the compatibility tool was done by other members, either current members or those who've already rotated off. So they all get the credit, and I'm glad I can be up here presenting it, but I didn't have anything to do with designing this really slick system. Thank you all. Here comes Ryan.
Thanks, Ted. So I'm Ryan from EPA, obviously from Office of Underground Storage Tanks. So you've heard a little bit about the compatibility issues with ethanol blends, but also about the diesel corrosion. So I'm going to talk to you a little bit about the report that EPA was able to put out this summer that looked at diesel corrosion that Mahesh and others have talked about. So you got a little bit of background from Mahesh already, so I'll go through this quickly, but a new corrosion issue came out since 2007 when the fuel started changing. Along with the sulfur change, there were some other associated changes to the diesel formulation for conductivity and lubricity, cold flow ability that had to change when the sulfur changed. And there were also some questions about the influence of renewable fuels and biodiesel and ethanol that could be getting in. And there were also some changes, as Mahesh talked about, in the storage infrastructure, and then also some of the transportation and distribution practices. So a lot of questions going on around this time that it wasn't quite as clear that sulfur was necessarily the cause of the corrosion coming out. So I'll go right to the answers here, what we found in the study before giving you a little bit more about it. But basically what we did a big study, and we found that there was a lot of corrosion in tanks storing diesel fuel across the country. We found that corrosion could probably and is impacting equipment. A lot of pieces of UST equipment need to move to operate properly. This corrosion could impair that. Could pose a risk of release of fuel to the environment. This is happening in fiberglass and steel tanks to metal components. And we just found that a lot of owners were not aware. So I'll talk a little bit more about that later. So the goal of the study, basically, this study was a follow-on to a large study performed by the Clean Diesel Fuel Alliance that came out in 2012. We wanted to build on that, work with industry to kind of further the knowledge based on what was already known, make sure we weren't overlapping. We figured that we probably weren't going to be able to get the solution immediately, but so what we wanted to do was kind of get a better understanding of the extent of how much corrosion was out there. Just like the corrosion and the compatibility portal, the tracking portal that they're coming out with. It's interesting as regulators, we hear stories coming in, and often we hear the worst stories, but that doesn't tell me if I heard about 5 of them in the last year, I don't know if that's 5 out of 50 or, you know, is it a lot more prevalent or 5 out of 500,000. So we wanted to understand how much was out there, and we also wanted to see if by testing the fuel and the conditions and everything we could about the tanks, were there any trends that we could pull out, anything that could help predict when corrosion may be there, when it may be pretty bad? So this report, interesting that we were able to do, I guess not interesting, but important to know that we were able to do a stakeholder review last summer of the draft, get a lot of great input, so we thank everybody for that. And then we went to a peer review in the winter and then came out after a lengthy process of being ready to put it out next month for a few months, that we got it out in July. So we looked at tanks across the country. We looked at clusters of tanks in different cities. We looked at 42 tanks. You can see the breakdown here. We had fiberglass and steel tanks. It was about half and half. We did the best we could. And we tried to get a pretty good representation across the country, but we know there's some areas that we definitely also want to look at. You know, Florida, the upper Midwest, Northwest, and Northeast are lacking, but we still got some pretty good spread. And we looked at a lot of different types of tanks. We had different owners who managed their tanks differently. The tanks were different ages, different fuel throughputs, different suppliers, different approaches to maintenance. So when I say we inspected these tanks, what we did is we did three things. First, we looked inside the tanks with a video camera and looked at how much corrosion was there. We got videos, and then a couple months later, we all sat down with popcorn in the oust office and watched 20-minute videos with no talking of the inside of tanks with corrosion. We also collected. Yeah, it was a lot of fun. It was riveting. Award-winning, yeah. We collected samples of the vapor, the fuel, and the water bottom that we could perform chemical tests on later. And we also collected that information that I said where we tried to get some more information about the background. We wanted to pull out trends. We looked at collected subjective information from the owners as much as was possible. But this was not, I guess we didn't get as much out of that as we necessarily wanted to, but you know, some of the tank owners only had one tank. Some of the people who participated in the study had dedicated teams, you know, and were fleets. And some, it was interesting where they kept their information. You guys are familiar with, you know, different ways of managing all the data on these tanks. So we gathered a lot of information, and then we essentially layered the data collected from the samples that we ran on the fuel and the water and the vapor. We looked for things that could signal theories that had been out there before, you know, and suggested by the first study that biofuels could be playing a role. So we looked for things that could identify that was a factor in the corrosion. We looked at, for example, tried to test for particulates and water, pH, and we layered that with the subjective information that we got and tried to pull out any trends. And we had the data people do some really complex stuff that was way above my head with the statistics, but those were interesting discussions. But what they found, as I discussed, that we found a lot of corrosion. We found a lot. We categorized the level of these tanks. The level of corrosion inside is minimal, moderate, or severe, and then we ran the statistical analysis. I should have said that. And we found that 83% had moderate or severe corrosion. Only a handful didn't have any corrosion, or didn't have moderate or severe corrosion. And not only did they not do that, we don't know that wasn't on its way possibly to having more corrosion later. This was a snapshot in time of the tank, so it was just, you know, we didn't have before or after. What we found really important is that most of the owners weren't aware that there was corrosion in their tanks beforehand. When we were coordinating with the study to find the sites, we were asking actively for volunteers or who could participate, give us access to the sites. And so the study is biased in that we went to sites where we asked for corrosion to be there. But even given that, when we went in, less than 25% of our sites actually said they had an issue. I said, I don't think I'm having any problem with my tanks, but you know, we'll help you out with the study. We know you guys need sites. But when we went back and looked, saw 83% had moderate or severe corrosion. Less than a quarter knew. that was interesting. And then I think that was validated a little bit by your survey that you did. And I saw on there, I think I wrote down quickly, tried to count that only 5 or 6 states reported that they had knew of problems or corrosion issues associated with ultra-low sulfur diesel. So it's a big out of sight, out of mind problem at this point that we are trying to, really want to communicate that information. The other thing we found is that there were no statistically significant predictive factors to say when there was going to be a lot of corrosion. You see the breakdown here with steel and fiberglass in the different colors, that in each of the categories, minimal, moderate, and severe, we had about the same number of steel and fiberglass that were affected. So I will go over this quickly because Michael and John will dive into this a lot more, and they've got a lot of great pictures. It'll be a very exciting presentation to close out. But what we're really worried about is that this corrosion really has an impact on what we're trying to do with our program. So we have leak detectors for a reason. We have overfill valves for a reason, ball float valves, shear valves, and we're just hearing that these things are having issues, and we saw that with the corrosion. Or we saw that in the study when corrosion was on there. We didn't do any operations testings, but pretty much if there was metal during the course of the study, some video showed that component being pretty coated in corrosion at some point. We also saw corrosion on the walls of steel tanks, and that could pose a release. Steel is always water maintenance has always been very important in steel tanks, but that the risk prior to the diesel corrosion was generally considered to be handled through very good maintenance practices, but this is something we're going to want to watch for. So the key takeaways from the study: corrosion is common. Many of the owners are probably not going to be aware of it. The corrosion, as we saw it, is geographically widespread. There don't really seem to be any patterns necessarily to where it shows up or where it doesn't. We do hear some regions northeast saying that they're not seeing it too much, but we don't know. It seems to be out there. Maybe it's more severe in the south and some of the more humid areas. I've heard a lot of reports in some of the coastal areas, but that's more information that we want to gather. Hopefully this portal, the information gathering will help us even further pinpoint, where these things are really happening. We found ethanol in 90% of the 42 samples. So while that doesn't lead to any conclusions in our study, it does on its own stand as a fact that there is evidence of cross-loading or cross-shipping or mixing of the fuels before it gets to the tank. I guess there is a chemical possibility of ethanol being created in a tank, but it seems pretty likely that between the tests we did for gasoline contamination and tests for ethanol presence, that the two matched up pretty closely. That it makes a lot of sense from people we talked to that there's some shipping issues going on. And I've heard recent reports about flashpoint measurement too that could show some effects of that mixing that could have safety implications down the road. So that's it's an evolving issue, but we're learning a lot of things on the mixing of the fuels. The quality, when we compared it to a handful of specifications, the ASTM, the CRC fuel selection protocol, it was mixed. Not all of them necessarily met all the criteria that were ideal selections for the fuel upstream. Given that, when we did the analyses, we saw that particulates and water were, the presence of those were closest to being predictive factors in the statistical analysis. Basically, if your fuel is clean and dry, there was a closer, not clean and not dry, closer chance of having issues. And that's what we hear from industry. Good practices: keep your tanks clean, keep water out of your tanks, probably a good chance of minimizing corrosion. Our study couldn't confirm or deny, I guess, the hypotheses from the first report that came out in 2012, but it certainly seems feasible that biofuels could be a component of feeding feeding the microbial corrosion, but there's certainly other things in the fuel or in the tanks that could be involved in that as well. So going forward, EPA, we recommend owners inspect their storing diesel fuel as part of routine monitoring. Mahesh mentioned the guide from the CRC, this 2-page guide that came out just about the same time as our report that really gives actions that owners can take on a weekly basis, how to take care of their tanks, minimize this risk. And we also put out a notice to owners that if you haven't seen it, we would like you to share it as much as you can with owners and operators to make them aware. And this basically takes the 50 pages of report and talks about what we saw, what does it mean for owners and what they can do about it. So we think this could have an impact also, emergency generator tanks, above ground storage tanks, home heating oil tanks. So some of these tanks are not even regulated by our program. This could have an impact on those, and you want to be aware of that. And going forward, there are resources available, a lot of resources, the SWOMOs as well, that talk about these issues and how do you do it. But in addition to the data and the resources for owners, we're going to have research continue. There are states doing research. The Coordinating Research Council is going to do some research. Information sharing, I really appreciate what you guys are doing, is going to be critical to making people aware of the issue and then getting the feedback from them as they become aware of the issue to tracking any issues that come out, failures, so that we as regulators can be in the position to know what we can do about, any vulnerabilities or how we can prevent issues going forward. That may be, working with standards committees. So we can look at standards for inspections and for fuels and for maintenance and then for the equipment itself. There's a lot of opportunities that we might be able to influence where, things that could help prevent this issue. Tracking is really important. And then also there are a number of companies that are working on solutions. Kind of even as the research goes on, we don't know what to do. There are companies that are coming out with products, approaches, technologies to minimize, mitigate any risk even before we come out with a final solution. So it's important work with those companies as much as we can to share information openly and allow the private sector to do what it does in addition to what we're doing as regulators. So at that, I'll leave it to these guys to go on with some good pictures and exciting stories of things in the field. So thank you.
Thank you, Ryan. So John and I, especially John, can talk about this all day. We have, oh, come on, that was funny. We have about 15 minutes, so in the spirit of Halloween, I decided to give you all a little underground storage tank system horror show. So here we have our little unsuspecting diesel tank out in the field that you're all seeing when you go out on inspections. What's going on inside that tank? And as you do your inspection, well, you can't really see inside the tank, but if you don't look for this stuff, trust me, you will not find it, so that's why a lot of people aren't seeing it yet. We are seeing a lot more leaks inside dispensers from meters, fuel filters, and this station in particular had a problem dispensing. It's like, I can't dispense any fuel, nothing's working, I don't know what the problem is. Well, he didn't know inside this meter is this screen. And, well, when you see inside the screen, you see why he couldn't pump any fuel. It's completely gunked up, nothing could get through it. That's why he was only getting a trickle at his nozzle. You look at it at the other angle, that might be a little bit of a better picture, but it's completely gunked up. Nothing can move through that. So we're not just talking about what's inside the tank. You really have to look at the entire system, all the way up to where the nozzle is. Everything can go, including your LLDs. Here's a PLLD. This was not in alarm at the Vita route. This station was getting all passing tests, 3 gallons an hour, 0.2 gallons an hour. Contractor came in to do an actual LLD test, and it failed. And he pulled it out, and this is what it looked like. When you look at it a little closer, nothing can get through this as well. If you flip it over, it's collapsed. It's not going to work. And this is what we're finding, and it's not limited to just PLLDs. Mechanical LLDs are having a similar problem. It's just disintegrating. What we are seeing inside of a lot of these tanks, as you pull the turbine out, the top of the turbine inside the sump looks great. Oh, there's no corrosion. All the gasoline ones, oh yeah, they're corroded. But this diesel one looks good. Yeah, pull it out, and this is what it looks like. As you look more towards the top, that's what it looks like. Probes. Well, see, the problem with probes having this issue is, well, in order for the floats to move, they work with magnets. So if you have a lot of rust inside a tank and those rust flakes are collecting on the magnets, those floats aren't going to move freely the way they should. So they're going to get weighed down, and they're not going to give you accurate readings. If you're relying on a 0.2 gallon per hour test for your monitoring, you might have a problem with it. So what happens? Well, you call a contractor up, they change out your probe, and they might clean your tank out. You might hire a guy to do some sweeping and filtering of your fuel, and this is what was at the bottom of the tank. It's a lot of sludge. Well, what happens when you get rid of the liquid? There's parts of his tank. Oops. So here's another one we found that was getting water in their annular space, only about a shot glass or so. I know, my priorities. So what was the cause of it? We didn't know. We vacuumed it out, ran a vacuum test. That wound up passing, so cut them loose. A week later, check it out, more water. Okay, do it again. Helium test, passed. A week after that, now he has fuel in his annular space. All right, now we have a problem. Now you got to really do something about it. He sends a guy in, and the welds on his strike plate had disintegrated. And look closer, it was all gone. He took the strike plate out to show to us. You turn it over, and all the pitting corrosion is underneath it. That's what the inner wall of the tank looked like. There were pinholes through that, and that's how the tank bottom was leaking into the annular space. This was an 8-year-old modern welding fiberglass coated steel tank. So this can happen pretty quick. Other pictures inside tanks, again, think about all the components that could corrode, the little things that you might not think about, your shear valves. There's just a little spring in there. That corrodes, it goes. Talking to contractors, roughly between 40 and 50% of them are failing when tested. It's a bit of a safety issue. So top right corner, you have the walls of a steel tank. They're corroded. Fiberglass tank upper left, think about the bungs. We've seen leaks at the tops of tank because of this happening. Your flapper valves, well, if that doesn't work, we could certainly have a problem. Bottom right, there was a ball float there, but the cage corroded and the ball is, well, it was floating around the bottom. So what can we do about all this horror? Well, owners and operators can go buy one of these liquid cold test kits. They cost about 20 bucks a bottle. You take a sample of your fuel, put it in the bottle, wait overnight, and see what happens. If you don't have anything, it'll just look like this. Like, okay, we're clear. Looks like that, you've got a problem. Pretty easy to tell. Now you have to call a contractor, do something about it. Something else, you do have stainless steel components that will last a bit longer. Yes, they're more expensive, but you're not going to change them out as much. You might save a little money there. Something we've been seeing in New Jersey a little more frequently is contractors getting in the fuel filtering and tank sweeping business. Since John's part of this, you know he probably has a video he's going to show. So we do have video. We do have video of this being done. We've been out on a few of them now. They try to vacuum out all the tank bottom, filter all the water out, clean the bottom if they need to. There's a series of filters involved here. You have a canister filter. You also have a filter screen. When the tank has a problem, they tend to have to change these filters out very, very frequently. This one had to be changed after 5 minutes because it looked like that. And the contractor usually knows when he's going to have to change it pretty soon, because if you look at the hose, you go from nice clean fuel up top, and here comes the sludge down the bottom. It's all black. If it's bad enough and it keeps gunking up filter after filter, and the stinger is, the contractor can just feel when there's just a lot of stuff at the bottom of the tank, whether it's rust chips or whatnot. They might have to send a guy into the tank to actually physically clean it up. And this one had to be cleaned up, and they pulled a whole lot of stuff out of the bottom of the tank. They also had to pull out the drop tube. That's the old one on the right. It kind of looks like it used to be a drop tube. It's not anymore. So we are seeing that a lot, and John has a really fun video for you. Some other things that people are doing, we are seeing people use biocide treatments. This does not change the environment inside your tank. It will get rid of the microbes that are in there at the time, but remember that you're pumping that out as you're selling it, so how long is it really going to be effective for you? It's not getting the water out of your tank, and as you kill the microbes, they actually give you a little more acid right when you do that as well, so it might not be a cure-all. What is, well, we're seeing some more people put linings in. Linings have been around since the 80s. The one with the strike plate, they put a new strike plate on and did a lining. Tank's been fine since then. You could try to inert the ullage portion of the tank. It's done in a lot of very large ASTs, the food industry. If you open up a bag of potato chips, well, it was nitrogen in there. That could help. It's, I don't know that it will help the bottom of the tank, but it might help the top components up. If you have a tank for an emergency generator, NFPA requires that fuel to be completely replaced depending on what type of fuel you have at certain intervals. If it's not biodiesel, it has to be replaced every 12 months. If it is biodiesel, every 6 months. The only waiver that they allow is with SAE J1488 version 2010 filtration units. There are contractors out there that have them. This was a standard that was adopted in Britain. They've seen a lot less of these corrosion issues since they've been requiring the filtering. It would probably be kind of tough to do that. This picture is actually just got sent to us from, I think John LeBlanc sent it to us. This actually came from a fiberglass tank that the fiberglass started to come apart, and they pulled that off the bottom. It actually had the consistency of pigskin, we were told. So a lot of scary stuff, and now John has his video.
Thank you, Mike. Good afternoon. I am John Olko from the great state of New Jersey, and Tara informed me that I am the closer, which that's a lot of pressure. So this is the last session of the day. You guys have been sitting around, listening, having a lot of great conversations in between, and I don't have any slides. That's my gift to you. I have a video. And Lon's sitting there with little cards with numbers telling me to stop and how much time I have. But Mahesh said, I have all the time I want. So You're not done yet, but we are good, seriously. The reason I'm giving a little bit of this video is I took a lot of these pictures that Mike had just showed at this site, and I shot this video back then, not really thinking that one day we would use it in this sort of form, but it's short, so I'll run through it a couple of times so you could follow it. The great work these guys have done on this task force, it's really going to carry through to, you know, I'm on the UST task force. Obviously, you can see what it's doing to the prevention equipment. But you guys in Lust and State Fund, it's coming your way. So the more you know about it, the better. And more importantly, I'm really glad to see this little one-page deal for our owners and operators is to get the word out. I try to push out your corrosion report as much as I can, and I think it's on all of us to try to get the word out to as many owners and operators, petroleum groups, whoever we can, so that more people are aware of the situation, what they can do about it. So I would just like to thank, you know, the Mahesh and his group for putting all this work together, because it's quite useful and quite important when you really look at it. And now when we start seeing it in the field, you know, I sit a couple steps away from Mike, so I'm sort of like a adjunct member of the Emerging Fuels Task Force, because I'm like, all right, here's some pictures, here's some stuff, and Mike takes it forward, and we're always talking. So these issues are really intertwined. It's really important to understand that. One of the things, you'll see the gentleman's hands with those blue great gloves, okay? And one of the things that when I was out there showing this, looking at this and taking pictures, we don't have the picture here, but I was walking around looking, and he's explaining to me how his, you know, system works and how he, you know, vacs the bottom out. And there was this pail behind me filled with blue gloves. I'm like, what's that about? He goes, oh, we got all those out of the tank. I'm like, what do you mean? Well, it's a diesel tank, so they didn't dissolve. And he says, well, apparently every time he was getting a delivery, now this was at a pump and tank contractor's. It wasn't retail, so he has the tank at his site to fuel his own vehicles. Every time the delivery guy came, he would, after he finished his delivery, he'd pull the gloves off and right down the drop tube. The owner of the company, who we know is an ornery old guy, heard this and said, wait until I get my hands on that blankety blank blank, who I have coffee with every time he comes and makes a delivery. So that was pretty funny, but I couldn't believe the amount of gloves that were floating around in this tank. It was quite interesting. So key things, we have a microphone, it has audio on this video, and you want to listen for two things. You want to hear the contractor's going to talk as he's using that stinger to vacuum the bottle. He's going to use the word crunch, and then you're going to listen for the crunch. Okay, so we'll go through it a couple times, and hopefully this works.
Down.
could hear the actual crunch, but that bottom had so much rust and deposits on the bottom that, sorry. That bottom had so much stuff. He just immediately, I don't know if you could see it, but that hose went from sort of a yellowish color to black instantly, clogged his filters. The vac truck was getting overpressurized and he had to shut it down. As Mike said, then they had to get into the tank, get all the fuel out, put a man in the tank and do it the old-fashioned way. This is one tank. We've got, I don't know how many out there where under the same conditions. I can play it again. I don't know if you'll hear it, but we can try.
A lot of crunchy here. A lot of crunchy. Oh, a lot of crunchy. I like that. Slowing down. I think our bottom's clogged. Yeah, our bottom's clogged. Okay, hold on. Let me just cut this off.
So, I don't know, I mean, our state, we have, you know, one or two guys running around doing this kind of thing for customers, but I encourage you, if you have anyone in your state doing anything like this, to get out with them, you know, and see what he's doing, how it works, and it's sort of enlightening from that perspective to see just how bad it could get. And then when he hands you the jar of crud, which we have sitting in our office, it's amazing, you know, what's really going out there when you could touch it and see it physically. It's really eye-opening. I mean, we could send, you know, Ryan here all the pictures in the world, but when you see it yourself, it's a different story. So hopefully, as the closer, I woke you up a little, I invigorated you, I maybe entertained you for a couple of minutes, and that's about all I have. I can take questions? Oh, apparently I can take questions, or any of these guys could take questions. Apparently we didn't have bios, so we didn't read any of that stuff, so that was another gift. So, yeah. And we'd like people to use the microphone, or the microphone maybe will be brought to you. Anyone?
I have a quick question. Being on the cleanup side, I see all these problems with compliance side. Are there any, is there any data out there to show an increasing number of diesel tank releases occurring? Is that happening? Are those being reported? I'm not sure. In my state, I'm getting any increased number of diesel releases reported. So are other states seeing an increase?
Oh, there you are.
So at least, I mean, I guess there's a couple parts to this, and Carolyn, you may want to weigh in, but I think so that we don't, at a federal level, require the fuel that was as part of the release to be tracked, I think is one issue. So part of the work that SWOMA was doing, the corrosion and compatibility tracking portal, is exactly what we're trying to do to be able to get some of that information that, you know, that we have, because we hear anecdotes, hear from regulators. I hear stories from you know, Mike and other regulators around the country that says particular issues, but we don't have any data or trends right now, so we're trying to work on that issue going forward. So any ideas as well, in addition to the portal are great, as well as any states that do have data on releases. That's really helpful.
I think yeah, Ryan said it best. We need to gather data to see if there are trends related to, like if there's an increased rate of releases that we're noticing in ultra-low sulfur diesel tanks. We just haven't looked at that closely enough. And I'd be curious if anyone in the audience in their states if you've noticed yeah, an increase in the number of releases, either small or you know, any sort of release from diesel tanks more recently, or at least after 2007.
And just to add to that, I think it's not just releases necessarily, but anything where you're tracking, you know, the rates of
failures.
Of component failures is really important too. The shear valves are hearing, we went to PEI last week and hear that that's a very common one, and that's a very important piece of safety equipment to have. And if they're failing at those types of rates, that's something that we need to look at. So for the overfill and other leak detectors as well, sure. Very important.
Hi, thanks very much for talking. My name is Brian Dabbs. I'm a reporter with Bloomberg BNA, and I'll just apologize in advance because my knowledge of this is very limited. And I was hoping you could help me brush up a little bit. With the emphasis on ethanol, I guess it was my impression that you're describing this corrosion as a recent phenomenon. So has there been an uptick in the corrosion rate or broad amount? And if not, what's kind of the distinction? Is corrosion a legacy issue? For instance, the last panel was talking about replacing underground storage tanks. Is corrosion also a motivating factor for that kind of campaign?
Yeah. So, yeah. The issues that we've seen with ethanol-related corrosion have kind of been evident for a little longer amount of time. And you know, when I had that first slide up, I was talking about when ethanol started getting blended into traditional gasoline fuel. And so we've seen evidence of ethanol corrosion and compatibility for at least a decade or more. With ultra-low sulfur diesel, that fuels, it's just about a decade now that it's been in the market. And so we're starting to actually look at in-tank equipment, and that's why the increased awareness of the issue. It was not as evident as it was with ethanol corrosion externally. Corrosion in tanks and compatibility issues in tanks has been present since fuels were put into containers. So there's different issues that cause that, and that's why in the federal issues change with time, and fuels change with time, and materials change with time. So, but yeah, the ones that we focused on most recently have been related to like the dominant fuels in the marketplace and looking at significant changes to their formulation and what that's done.
Mahesh, I was wondering. Perry? I think you probably hear me. I was wondering, since you did go to the PEI conference, it would seem to me this would have resulted in quite a few claims being made against the manufacturers. Have y'all done any investigation interviews with the manufacturers about the claims being made? Because I would imagine this is happening to brand new tanks as well as tanks that have been around a while.
You mean?
What's going to be really interesting is tomorrow's session. Tomorrow at, what time is that morning session? 10:20. We have speakers from the fiberglass and steel tank industries, so we can talk lots about that tomorrow. And I think they're actually here now, so maybe you can talk to them on the break. I think this is an emerging experience for all of us, I think, is the real answer. So we're still exploring the situation and trying to learn more about it.
And Mark was going to add something.
Yeah, I'll just add that at the PEI convention, though, the diesel corrosion issue was one of the big sort of buzzes of the show, and there were a lot of people there working on and trying to sort of show the potential solution that they're coming up with. And these are a lot of sort of the service providers and the equipment manufacturers. And so there was a lot of discussion about it. A lot of people, you know, tugging on our shirt sleeves in the hallway as we were walking through, and hey, come take a look at what I have. And we saw some of the solutions offered up here. It's sort of attacking without necessarily knowing exactly the root cause. I think there's a general sense that the microbial corrosion is really doing it. Why that's happening, there are different theories, but that is happening. And so people are trying to attack it for either killing the microbes or changing the environment so the microbes can't live, whether it's getting the water out or the nitrogen blanketing to get rid of some of the oxygen. And so, you know, filtering systems, nitrogen blanketing, there were lots of people sort of sharing, you know, the magic elixir in terms of the biocides and what kind and how often you use it and all that. So it was definitely, because those in the industry were working to develop solutions to it, it clearly is a common enough issue for them to invest in solutions to it. I would just add that. I don't have any information about whether people are getting, you know, any kind of private lawsuits or anything. We wouldn't even know about that really. But
any other questions?
I've got a question. I've got to be careful. I'm a cleanup person, so sometimes I may have a crazy question. But thinking of compatibility, we have a tank owner who uses a lot of naphtha in his fuel, a larger than normal or typical level. And I'm wondering, is that possibly a compatibility issue in any way? Because we had a release the other day into the groundwater from a gasoline tank that had 45 milligrams per liter naphthalene show up. Now, that's a lot for a normal gas release to have reported. So is there any possibility that an increased amount of naphtha in fuel, could that cause in any way compatibility issues?
I think, I mean, that's a great question. Yeah, fuels have a certain, they're supposed to have a certain specification by ASTM for gasoline, for diesel, for different fuels, and most fuels are blends. Yeah, gasoline's a very complex blend, and so you have hundreds of components in there. Changing that ratio certainly could have effects, but again, yeah, people are blending it to stay within the specification, hopefully. And if it is within specification, that's the fuels that UL has tested against. And so you have a little higher level of confidence that with those fuels or spec fuels, there should not be compatibility related issues. But when you, again, I don't know, it varies.
Sitting here thinking, and that kind of popped in. And also, is this a potential data set that would be helpful in the future for us to try to develop? Is we report number of releases, but EPA doesn't get that 5 of them were from waste oil tanks and 6 of them were from gasoline and 12 of them were from, you don't get that. Because that, now a lot of people may go, boo, don't start that, but I don't know. We're always thinking of new projects for our task force and collaborating with the other task forces. Is that a possible question that might need to be answered in some way in the future?
Yeah, I think it certainly would be helpful for us to look at actual trends, because if you just have releases, you can't say that the increase is because of diesel releases if you don't have the data. So I think it certainly would be helpful, at least, and it may be something we'll pull up in our next survey. to see if states can provide some of that.
Well, I think to Jordan's point, it should be a cross-survey.
Yeah. The other thing, and some panel talked about, is it may not even be a release. It's equipment functionality, and that could be, is really concerning too. Is that, as Michael pointed out, the failure of floats to operate as they were designed to operate, on your ATG probes and things like that. If there are no other questions, I'd definitely encourage you all to reach out to us. We'll be here this evening at the reception and through the conference, but also kind of check out the report and really the task force members. They are your regional, your regional reps, so reach out, get to know them, and share information with them, because I think the success of all we do is really through your participation, and I'll let John close.
All right. One more quick thing. On that one slide, water is the common denominator, so water management is really key. And what Mike showed earlier on that float with the rust on it, the ATG probe, okay, what's that probe no longer going to pick up? Water. So that operator's monitoring system is going to show no water. And he has water.